So hello guys, in today's video we are going to see the question union of two sorted array. Union of two sorted array. Okay. So in this particular question what you need to do is you will be given two arrays that will be ARR1 and that will be 1 1 2 3 4 5 and another one will be like you can take any one so 4 4 5 and 6 and what you need to do is you have to take the union of the two arrays and this will be the both will be given in the sorted order and also you need to just merge it or you can say union it in the sorted array. So first of all let's understand what is the meaning of union. Okay, if it has said like merge, then you can like you can normally do like 1 1 2 2 3 3 4 4 4 5 5 and 6. This is the meaning of merge, not union. Union is a type of concept in set, which means every element would be only once, because in set you only store this type of element only once. Okay, so what you need to do is just you do not have to do this. What you need is just take the all the element once time. One is appearing 2, so take one only once, then 2, then 3, then 4 and then 5 and then 6. This is the particular thing that you need to return, and also it must be in the sorted order. So you have understand the problem. What is it asking you? It is not saying you to merge the array, it is saying you to union, which means every element would be appearing once. Okay, so let's see how can we store all of these elements. Okay, so there is a way that you will think you can store all the elements in n set. That is right, which is the brute force solution. So let's see how it will work. Since set is a data structures in DSA, or you can say in any particular language, it is a general concept in which if you will store any particular element, like I have stored 1, and if I again try to insert 1, it will not create a replica. It will say that 1 is present, do not need to insert, means it will keep unique elements. So 1 is there, so no need to worry about it. Just take another elements, so it will insert 2. What the brute force will do is first traverse into the first array and then traverse in the second array. So if I traverse in the first array, first 1 is inserted, I move forward, 1 is inserted, no need to do, move forward 2, so 2 we have inserted over there, move forward 3, we have got 3, so put 3. Now we have got 4 over there, so just put it 4, since there is no 4, so we have put it, move I forward for 5, check 5 is there, not, so put it. Now start iterating in the second array. You see that 2, okay, check 2 is here, yes it is here, do not need to do anything, move I forward. 3, do 3 is here present, yes it is present. Check for 4, do 4 exist in this set? So you see that yes 4 already exists, so move I forward. Again 4 is there, so do not need to do anything. 5 is also there, do not need to do anything, move forward. 6, you check that 6 is not there, so just insert 6 and move I forward. I ended the both array, and at the last you have got this particular set. Okay, so in Java if you take normal set, then it will store everything in default format. So in Java you need to take tree set so that it will be automatically in the sorted fashion. Or what you can do is, since what I have told you, it will iterate in the both array, so first initialize the set and let's code it up, and then I will explain you what I am trying to say. So first what we did is I0 to whatever the length of this array is, let's suppose n-1, so just say that set dot add or push whatever it will. So set dot add ARR of I and Same for the second array, I would be 0 to, let's suppose this size is n and m, so m minus 1, and you say that set dot add arr of I. Okay, arr1 and arr of 2. Okay, so now what I'm trying to say you that is, after inserting this element, maybe if let's suppose from this I think maybe this have contained let's suppose it contains 9 over there. Okay, and also I think I need to change the array. Okay, yeah, so 9 is there, so after 5 9 would be there. Since let's suppose 9 is also there, and again let's check this. So initially I would move normally and put everything like 1 2 1 2 3 4 5, and instead after 5 it will put 9. Okay, you have now got the idea. And after this, if it starts checking this element, so at first it will say that 2 is present, move I goes here, checks 3 is there, okay, no problem. 4 is there, 4 is there. 5, yes, 5 is there. And now check 6 is not there, but it has seen that 6 also need to be there, so it will put 6 in this set. So what you see over there, set is storing it in the unsorted fashion. Then at the end you need to sort the set, and then you can convert the set into an array, or you can say first convert the set into array and then sort the array. So one is this solution, and another, instead of sorting at last, what you can do is, for Java people, you can take a tree set so that it will be sorted. Whenever it will be inserted, it will automatically get sorted, so do not need to sort like in the code. It will take almost the same time complexity, but if it takes inside this, then it is comparable less, it will take comparatively less time, but not that much. And for the C++ people, I think there is a sorted set, I don't know exactly, but in the code I will tell you. So this is the particular concept of brute, that first you need to take the set data structure and just put whatever in the first array and then in the second array, and if you have taken normal set, then you need to sort it and convert it into array, and then you can return. So this is the brute solution. I will show you the code. So there are two arrays given in this particular code, A and B, and we need to find the union of the array. So in the brute force, we need to take one set. So let's take a set of integers, because in the array you will be containing integers. So set of integers, set is equal to new. First I will tell you normal set, then I will show you the sorted set, so that you can like do it in a better way. So new set, and so what you need to do is first iterate in the first loop int x colon a, and just say that set dot add x, and do it same for the second array. And now what you need to do is since all of the thing are in the set itself, so now you need to convert it into an array. So what you will do is array list of integer, and result will be new array list of you can pass the set over there. Let's try, is it working or not? So you can directly return it, and let's check it out, it is working or not. So cannot be instantiated. Okay, I need to, I think, take a hash set. Yes, let's see. So yeah, as you can see here, the case, it is correct. Let's submit it. It got outputs that oh, okay, since it is not sorted, everything is there, but actually it is not sorted. So what we need to do is before doing this, just say uh, collections dot sort result, and let's again try. Mm-mm-mm. So as you can see here, before returning, you need to sort everything. And if you do not need to like sort it separately, what you can do is you can take a tree set. So what tree set does it will add the element in the sorted array itself. So you not need to externally do it. I'm commenting this so that you can also find it. Uh, let's keep it there. The first we have used is hash set so that you can remember it. So now we have taken tree set. So according to tree set, in the set itself, everything will be sorted. So do not need to externally sort it. So I have commented this part and again try to check this. And you can see here it is working fine as the same. And even what you need to do is do not need to store in a separate variable. Just I commented down and only just you need is this particular part and instead of returning result you can directly return it like return new array list. So it would be the same thing. Just check it also it is working or not. Yeah, it is working. So yeah, successfully completed. Let's move on to the optimal solution. Optimized solution. Optimal. Yeah, optimal. So same. Let's first take the array. That would be 1, 1, 2, 3, 4, 5, and ARR2 will be 2, 3, 4, 4, 5, 6. Okay. So let's see how optimal solution works. Okay. So what optimal solution will say, you will take two pointers, I would be at this position and j would be at this particular position. Okay. So I and j are there, and you and take also a merged array that you need to return. And you check that which element is the smallest, the ith element or the jth element. So this is the smaller one, so just put it into the array. Okay, now whatever you have taken, suppose we have taken I, so move I forward and again check that this is the same, the last element is same this particular element. So it is the same element that we have inserted right now. So do not need to consider, move I forward. So I is move forward. So 2 and 2, since it is same, or maybe you can take, yeah, it is same. So you can put 2, or either you can increment I or you can increment j. So just put 2, and let's suppose we just considered I to forward. So we incremented I. Okay, so check 3 or 2, whichever is the smallest, 2, but check that in the merged array the last element is also 2. So you are not going to insert this, just increment the jth pointer. So jth pointer is there. Now you need to check I and j. So compare, is 3 less than or equal to 3? Yeah, it is equal. So put 3 into the array and move the ith pointer. Okay, no problem. Now check I and j. So 4 is bigger and 3 is smaller. So we are saying that we need to insert 3. But check, in the merged array the last element is also 3. So you are not going to take this, just move j forward. Okay, no problem. J is there and I is there. Now compare I and j. I and j are both are 4, 4. So we moved I to the forward, and we just keep this element 4 and I is moved forward. And then now check I or j, whichever element is the smallest, 4. But check, 4 was recently inserted, so why to take 4? Just only increment the jth pointer. Now compare which is the smallest, this 4, but 4 was the recently inserted, so no need to consider, move forward. Now check which is the smallest, so both are same, so take I and move forward. So 5, and you move forward, but after moving you observe that this array is now completed. So after this, whatever element would be there it will automatically in the sorted fashion. So you only need to check, is this particular array is the same element? So yes, so do not need to consider, only move j. Now 6, so check 6 and 5, they are same, no, so put and also move j. So now j got out from the array, completed. So this is the final array. It is similar concept like merge sort, because also in the merge sort what we were doing, we were just comparing the values and inserting it into the particular array. So it is same concept like merge sort. So let's check out the I will show you the pseudo code, because the actual code will be too longer and there will be much like quite more edge cases to consider. So I am showing you pseudo code to understand. So initially take I and j pointer to be at 0 index. Okay, no issue. Now run a while loop. While loop for what? Until anyone of from the array becomes empty. So while I should also be, let's suppose this size is n and this is m. Okay, so it is also less than m, and j is also less than m, which means in this particular while loop everything would be in between the array. So what we were doing, just check that ARR of I is less than equal to ARR of j. Then what we were doing, we were just first check that if the merged array contains it or not. So first we check that condition, yeah, it is less than. Now again check that if the merged, or sorry, I have taken the wrong name. Instead of merge you can take it as union, because you know it will improve your code quality and also for other to understand. Take the name as understanding and as correct, so union. So check in the union array. Let's suppose for checking this we have a method like back. So union dot back will tell you whatever is the last element. So is the last element is not same, then only you will put. So check that is it the same, because we are considering I, since it was less than j, that's why we are checking for I, union last element and the ith element, ARR of 1 ith. So if it is not equal to, then only you can say union dot add that element ARR 1i and just do I plus plus, because you did the thing right. So you have checked this and you have I plus plus, you have done I plus plus. And what was the second condition, that in this if I was smaller, so else case would be that j will be smaller. So in the else case again check that union dot back, like what is the last element, is should be not equal to the ARR 2 of j, that should not be same. So check, and if it meets the condition, then only you put into the union array to j and increase the j and the else condition, and also close the while condition, because this while was only for checking until anyone gets empty. So what after empty? Also after empty you need to check and also insert. So first let's see what if the ARR of like ARR 2 or 1, maybe whatever you can say. Let's suppose ARR of 1 is empty and ARR of 2 has some element. So you check that j is right now less than m, because we were taking m as the size of the ARR of 2. So first you need to check that union back, is it the same element or different element? If it is like ARR of 2j, if it is different, then only you add the element to the union array. So ARR of 2 of j. Okay, and increment j until it's get to the end. And same for the ith if the second array is empty and first array has some elements, so I would be less than n. And if check the union back should not be equal to the arr of arr1 of I. Okay, so if it is different, then only you need to add that arr1 of I into the union array and do I plus plus and this, and after this only you need to return the array, because everything is done for until it is going to end any one of the array. You will need this particular for loop, and after this if any element are remaining in whatever in the second array or for the first array, it will add it by this concept, and at the end you will get the union array. You can return this. And what is the time complexity? Since you are only traversing it once, you can see the pointer, I was only going to traverse one time. Okay, and m was also going to travel only the like what was the size, so the overall time complexity will be time complexity of n plus m. And also what is the space complexity? So space complexity is also big of n plus m, because we are taking union array which will store what number of element, addition of both, and also we were traversing the same, so time and space complexity is the same for this particular code. So now let's check out the optimal solution. So in the optimal solution, what you need to do is you will carry two pointers that you will need to iterate on both the arrays. Okay, so first let's take its size a dot length, and then int m will be b dot length. Okay, and take int I would be 0 and j would be 0. And what you need to do is take one array list and integer, let's say it as result. Okay, what you need to do is first you need to go until someone from this or this particular array gets empty. So go till that particular point, and what you need to do is check I is smaller or jth element is smaller. So compare a of I is less than b of I. So what you need to do is if a is smaller, then you need to put a element into the result. Okay, but before adding it, you must check that whether it is the last element or not, as I have explained you. So first you need to check that result dot who result dot get. How you can fetch the last element? You can say that result dot size -1. I think let's try it. If I will get error, then we will resolve it. Okay, so that must not be equal to the current element, so this must be checked. And the another condition is if the result is empty right now, so how you will find this particular thing? So you need to first check that thing, that is the result set empty. Result dot size is 0. If it has size 0, then it can directly move inside and do the task. And if it is not true, then it will check that last element is the same or different. Then it will simply just do result dot add, and what you need to do is a of I. So a of I is added, and in the else condition, b is smaller, so you need to put b. But before putting b, just do the same thing, only you need to check for the b. So result dot size same, and result dot get this also be the same. This needs to be b, and also you will put b over there. So this is the condition for when the both arrays like both the pointer will be under the n and m. And what do you think after that? So if it updates it, so it also needs to update the ith indexes. So accordingly update it, and here it would be j, I think. Yeah, j. Also here it will be j, and you need to increment j plus plus. Okay. Now let's do the second thing, that while j is less than m, which means the first array is completed and the second array element are left. So again check the condition, this particular thing. So you can copy the condition exactly the same and put it inside this, and you can say that if it holds true, then only you will add, because this particular condition remains constant. Okay, so what you need to do is just result dot add, and since it is the second array, you need to add the b of j and do j plus plus. Okay, and after it, what you need to do is you can put it here, right? Okay, so just move it outside, because if the condition doesn't meet, then it will maybe go to infinite loop, so better to keep it outside. So do the same thing for the ith ith index. uh, just replicate it down, and for ith element, what you need to do is change j from I and m to n, and this is same, here it is same, you need to change b and j to I, b to a, j to I, and here also I plus plus. So it will add the element in the result array in sorted fashion, and at the end you need to just return the result array itself. Return result. Let's try it out if there is any error or not. Yes, result that size must have been initialized. What happened? Okay, I have not initialized it. So new array list, and yeah, now we have initialized another array. Everywhere is the same error. So again, let's try. Okay, runtime error. The main out of index. Okay, line number 98. No, I think there is any particular mistake. Let's check it out. We have initialized n and m as a size, and also I and j, and initialize the array list that need to be returned, and then I must be less than n, j must be less than m, and then this would be equal to, or maybe you can, it is not necessary to put equal to. If it is an empty, then you can add, and another one is if the psi is the last one. Do this particular thing works, because maybe this can cause an issue. Let's again try that. I think no, the same error. Okay, so what I have did is I have put it an and condition. That why it is giving like that. We need to take or here, because this can happen individually. You do not have to take both of them. So there is an or condition. So only just update it, and again let's try it out. Yeah, now it is working. So yeah, in writing code there might be bug, but you need to resolve it. So let's try to submit it, and hopefully it gets submitted, and yeah, it works fine. So this is the particular optimal code as you can see here, and this was the brute force code that I have told you earlier. So the time complexity of this is big of n plus m, and also the space complexity is the same because you need to store all the element in an result array. And for the brute force solution, the time complexity is again you are traversing in both the arrays. So For traversing, it would be n plus m till here, big O, n plus m. Okay, and to sort this up, you need extra n and log n, right? But if you are not considering this, only you are taking tree set, then it might be log n. But overall, if you say it is an n plus m, overall n plus m, and then log n plus m. Yeah, this is the time complexity.